got another video tonight. So been working on my SSR project for a while now, and just about to go into revision 2, but I wanted to do some more measuring before I built and designed my second board. I've already got it done. I just wanted to make sure that everything that I made a mistake on this board will not go to the next board. So tonight I just want to show you how I've measured this to see the reaction time of the SSR, and then show you the bench and show you a couple screenshots of what the circuit kind of looks like. I'm not going to give all the details, and I'm going to put in a screenshot of how fast it is. I did do some measuring today, and I got it to 120 nanoseconds for it to react. For any of you guys that don't know what an SSR is solid state relay, and it's for an audio amplifier. So normally an amplifier uses a relay, but relays can fail and they can have other issues and stuff like that, whereas a FET that switches on and off to pass AC, as audio is AC, will never wear out. There's nothing to wear out. And these little FETs that I'm using right here, the IRFS 4610s, can handle up to, I believe it's 15 amps of current. Plenty for what I'm going to do. I believe that's probably good for about up to 1,000 watts. And all the amplifiers that I deal with and work on and stuff like that and build will never go that high. I am working on an 800 watt monoblock, but I'll change the FETs to something different. So anyways, I will show you how I've done it on the scope and a couple screenshots, how I captured the data, and then I will show you a couple videos, or not videos, but a couple pictures of how the information looks. Okay, so hopefully my focus is working. So we'll turn on the scope first, because that takes the longest, the bench meter, and my power supply. Little setup way here. So we have the SSR, just measuring DC voltage with these two. We have a scope probe set up, and we have the second scope probe set up, and then the stuff. So we'll turn the channel 1 to 12 volts to turn on my SSR, because it works on 12 volts. And then we'll hit current, and we'll give it 60 milliamps. We'll turn it on. Blue light will come on saying everything is steady, has no issues. It's not detecting any DC. And then we'll go to channel 2, and we'll ramp it up to, say, 25 volts. No reason why I'm putting it to 25 volts. It's just an example of rail voltage. That's why I'm using channel 2 to put across the 1K resistor here to emulate that the SSR is detecting rail voltage, and then it goes into protect mode, and I'll show you that in a second here. So we'll give it 25 volts. We'll give it 20 milliamps, and then we'll go on. So it's on. So I got a pair of leads here down to here. So you'll see that the SSR is on, it's functioning. And if I put 20 volts in to emulate that the amplifier has gone into fault mode, that would be connected to here and here. So the amplifier signal comes into this FET and then is switched on. So when the amplifier or the SSR is on, these two are basically like a relay where they're conducting like this. The signal will flow in and out to the terminals over here. Right? I took the little transformer off, which is this little guy, just so, because I keep touching the board and it's 110 volts right here, so I was like, you know what, let's play safe here. So let's emulate here. 12 volts for the module to run at, 25 volt for the rail. I can go higher, but there's no real point. And as soon as I touch this lead, which is the pair, to the positive, this SSR will go off. Perfect, just like that. It just emulated that there was voltage coming into the SSR and it was emulating, and it came back on because there's no voltage. Normally when an amplifier goes into fail state, that light will go off and the SSR will be on fully or off fully, so that's protecting the speaker because the speaker connects to this. So the next thing I'm going to do is I'm going to show how to do a capture, and I'll show you, I'll plug this in so I can put a little screenshot into the video here of detecting and showing how fast the SSR actually works. So we're going to go to single, and right now it's at 31.6 millivolts, which is above what it was showing here. 25 volts, and we'll see, I'll do 2 videos of this. We'll see the blue light go off, so there it is. It's off, and there's our capture. Now this is really squiggly and it's not really that nice and clean because it's a FET, right? So right now we've got 148 nanoseconds, and if we wanted to, I can change my window to the first time here. I believe I can make these go like this, and basically from here, let's go like this and change our starting point here actually. From here all the way, oh, wrong one. Yeah, all the way over to here is 120, 125 nanoseconds for the SSR to react. I'll put this screenshot in here, so actually we'll push print screen, and I'll put that into the video. And the SSR is back on and working. So what I'll do is I'll clear this and I'll actually hit it, and you'll see this actual work. There we go again. So we've captured another one, so it's stopped. We can't see it too well, but it's stopped, and there's our SSR running, and then turns off right there. And we got 128 nanoseconds. Pretty sweet. I've been working on this project for a long time now, and it's functioning, working. Now I'm going to go on to the next revision. I think as I showed you guys in the last video of my SSR project that I made a mistake when I designed my circuit. I forgot to run a jumper from here all the way over, which was a mistake. When I did my design, I used a net symbol and I forgot to connect them in the board, but that's simple. And there's a little resistor right here that I just popped in there because I had a whole bunch of different values because I was changing the timing. And yeah, but pretty cool. I'm pretty excited that I got this going. It's working, it's functioning. As you guys can see, my bench has changed a little. I got a new device up there. As one of my videos I was talking about, the Q401. I'll be learning more about using that. And yeah, so give me 1 second to change my camera position, and yeah. Okay, I'm back. I got my Thomas CAD drawing here. I'll thank Thomas again for helping me make the circuit work, and he's also helped me on revision number 2. And I've also got a stereo version coming out pretty soon here that I'm going to be working on a board in the next couple of days, maybe weeks here, depending on how busy I get. And this will be, I'll have a version coming out that won't have the power supply on it, and you'll be able to use that. So I'm going to put this picture up in the video, and in the video you'll see that we've got DC in for channel 1, and then we have our trigger point for the transistor to detect when the light goes off, which gives us our timing. And that is what we were measuring to show how fast, when we put a DC voltage in on the input for the sense, and how fast it takes for the circuit to work to turn off the FETs to protect the speaker on the output. So just a quick little video I'm not sure if I'm going to throw up the schematic. I probably will throw up the schematic, but I'll erase all the values on there so nobody can see it, because I've worked really hard on this schematic. And again, thank you for Thomas helping me a lot. It's been a goal to actually work on one of these. There are other designs out there that people have designed, but mine's just a little bit different, where the power supply is on board and it's all contained in one. There are some other designs out there where they have all the FETs and stuff mounted to it. Anthony Holton from, what's his website now? Precision Audio, I think. No, not Precision Audio. Holton Precision Audio. He has one that's a really good device, but he incorporates the triggering circuit, as you will, you want to call that, onto his amplifier boards, whereas these that I'm designing are a self-contained unit that can be used on other amplifiers, like such DIY chip amps or Class A amplifiers or AB amplifiers. And I'll go into more of depth of that later on, but my main goal was to build the SSR, get it working, and it works great. No problems at all. I've tested it with my amplifier over here. But the main point of this video was to show how fast it's reacting and to prove to myself that it actually does work 100% the way I dreamed it to work. So I do have a couple different versions, lots of ideas of how to evolve this and get it going. So I'll throw some screenshots in the video with me docking, and throw in the screenshot of the scope with the 128 nanosecond time frame to show you guys. And yeah, just a quick little video trying to get used to talking to a camera and getting used to it and stuff like that. So always evolving ideas. I lose a lot of sleep nowadays because I'm thinking of things I want to video and do and bring my channel forward and actually do something with it. And we're stranded at home anyways, so I thought, why not work on electronics and improve my electronic skills and stuff like that, and go from there. So that's it. Hopefully the video was good. If it is, like it. If not, put a thumb down. Comments are welcome. Suggestions are welcome. And thanks for watching, I guess. Thanks, guys.